Hello everyone. So we're going to be going over systems of linear equations in this lesson. It's 8.1. I wanted to show y'all real quick before we start doing the specific problems. There's three options you can select as your answers. So option A, the solution is x equals and y equals. I'll give y'all an example of that. B, there are infinitely many solutions. Using ordered pairs, they can be expressed as x, y, where x equals and y is any real number. And then the other option is, I'm off to a good start with it being touchy. The other solution is that the system is inconsistent. Wow. Okay, so from over here, so I can show y'all, this top option is going to be, I pulled them up on Desmos, and this is not the equations we have on problem 1. This is just examples of options A, B, and C. So we're going to go over problem 1 in a second. So on the option 1 where you can put x equals and y equals, this is what they're looking for. This is what our first problem is going to look like, but this is not the first problem. So when there is a solution to a systems of equations, it's where the two graphs cross. So our answer on this one would be x equals 4.5 and then y equals 1/2. Well, 1.5. And then option B right here, there are infinitely many solutions. Using ordered pairs, they can be expressed as x equals when y is any real number. So that's going to be this next option. I believe it's this one. So right here, there's only one line. The reason there's one line, I'm going to delete the 8 off of this so y'all can see it real quick, is because they are the exact same line. You can look at the equations on these and kind of tell, because our second equation is just multiplied, the first equation multiplied by 3. So our first equation is 2x plus 3y equals 6, and our second equation is 6x plus 9y equals 18. So when they're looking for a solution on this one, they want us to do x equals where y is any real number. So you're going to take either of these, because whichever one you solve, they're both going to be the same, and solve it for x. So I'm going to do the top one because it's already reduced. And if I'm solving for x, I'm going to go ahead and subtract my 3y. So it's 0 over here. 2x equals, I'll do negative 3y plus 6. And then divide by 2 so that x is alone. Anything divided by itself is 1. So I'm pretty sure when you type your answer in on these, it'll take it like this. You could separate it to be x equals negative 3/2 y plus 3, because 6 divided by 2 is 3. But I think they'll take it like this as well. So this is when it is infinitely many, and they have x equals. You're going to have to put an equation on that. And then our last option is the system is inconsistent. So what that looks like, I think I'm going to have to, oh, it went away, is that the two lines are parallel. So I have y equals negative 1/2 x plus 4, y equals negative 1/2 x minus 2. I'm going to pop this over here. And woohoo. Oh wow, that's kind of crazy. I didn't mean to do it that much. So these are parallel lines, so they're never going to cross, and a solution to a systems is where they cross. Parallel lines never cross. Remember how to tell that parallel lines? It's because they have the same slope. Parallel lines have the exact same slope. Same sign, same numbers. They could reduce, like if this one was negative 2/4, that's still 1/2. But if one of these is positive, it's not parallel. You can always check any of these problems though on Desmos, and I allow you to, I'm getting so tongue-tied. I allow you to use Desmos on your test So I think this is great because we're rushing anyway, and our next lessons are harder. Okay, so let's go ahead and dive into our problems. I'm going to come over here so I can actually get it to pull up. So ours is going to have a solution. It is going to be A because it is not the exact same line and it doesn't have the same slope. Yep. Okay. I'm going to do this one algebraically and then we'll go ahead and put it into Desmos and check it. So in my head when I do these, there's a bunch of different ways to do these. You can solve it by substitution. You can solve them by elimination, which is what I'm going to do on this problem. And then you can solve them by graphing. Graphing is probably going to be our fastest way to do this. But I'm going to go ahead and show you elimination on this. So here, when you eliminate, you just have to have two that have opposite signs. So like I have a positive y and a negative y. So you'd add your two equations. X plus x would give me 2x. 1y plus a negative 1y would be 0y. So that's why this one is elimination. And then I'd have 3 plus 1 is 4. And then I can go ahead and divide by 2. So my x is going to equal 2. I don't know where I want to write that. And then to solve for my y, I just take this value and put it into either of these. Since y is negative on this one, I'm going to go for the top one. But either one you do, you would get the same answer. So I'm going to do 2m for my x on this equation plus y equals 3. And then you would subtract 2 because you have to solve for y. And y equals 1. So my solution to this system is 2 and 1. I don't know why I'm getting so tongue-tied. So I'm going to delete my math on this. I'll leave the x equals 2 and y equals 1 for us. Really? Okay. So when you graph these, you can graph your solution, that 2, 1. X is 2, y is 1. And then you need one other point, because if you're graphing a line, you need 2 points on that line. So if I wanted to, I could put 0 in for y and get my x-intercepts on both of these. So if I put 0 in here, I'd end up with x equals 3. So then my point on that one would be x equals 3, y equals 0. I wonder if I can. So this is our solution right here. This is going to be my extra point for my top line, my extra point for my bottom line, because you have to have 2 points to graph a line, is going to be x equals 1 and y equals 0. So I'm going to go ahead and do the 3, 0 first. So I put a point on here already. That is our solution, that 2, 1. And then I'm going to go ahead and do x is 3, y is 0. Now I have to graph my other line. So I'm going to do 2, 1 again. And then my point that I found is 1, 0. So x is 1, y is 0. Save. Check answer. You can also use Desmos if that is just a lot. I know 8.6 is systems of nonlinear equations, so Desmos is super helpful on checking on 8.6. Oh, solve the systems of equations. If the system has no solutions, say that it is inconsistent. Graph the lines of the system. So looking at this one right away, it doesn't have two that are the same value if I was to eliminate. I can use elimination still. I need to multiply that top equation by 4 though, because it's 3x minus y equals 7 and the bottom is 2x plus 4y equals 28. I could also reduce that bottom equation too, but let's go ahead and say we're going to multiply the top by 4. When you multiply, you have to multiply the entire equation. So I'm going to do 12x minus 4y equals 4 times 7 is 28. And then this one, since it already has the 4y that has the opposite sign, I'm just going to bring this equation over so they're lined up, and I can use elimination again. So when we use elimination, we're adding the two equations. 12x plus 2x is 14x. Negative 4y plus 4y is 0. That's why we did this. And then 28 plus 28 is... that equal sign didn't make me happy. Can I grab it? 28 plus 28 is going to be 56, I believe. And then divide by 14. 14 goes into 56 4 times. I'll double check. And if that is right, then we just take our x equals 4 and plug it into either equation and solve for y. Yep. Okay, so we're gonna go, I kind of just want to put it into the bottom equation. So I'm gonna take my x equals 4 and put in here. I'm going to do that over here. That's one thing with these. I wish I had a little bit more room. I wish I could combine the light board with this so I had more room to put all these thoughts in big enough so y'all could see them, because I know the problems are small when it's like this, but when I zoom in, then it's a whole thing. Okay. And then we'll move our 8, so opposite of positive. 8 subtract 8 would be 0, so I'm just going to have 4y equals 28, subtract 8, which is 20, divide by our 4, so y equals 5. Cool. Let's make sure they weren't linked together. Okay, I'm going to go ahead and type that in, and then I'm going to get rid of some of that math for our next part. 74 is not it is just 4. And then our y value is, okay, let me get rid of that now, actually. Okay, our y value is 5. Okay, and then be gone stuff. And if you're ever confused on this, seriously, Desmos is just, it's clean, it's easy to use. I could go type this in it real quick. I will. Why not? I know when I show students Desmos, though, they tend to not do it algebraically. And if you're taking the ACT still yet for either nursing or your concurrent student, you need to know how to do this by hand. So we have 3x minus y equals 7. I'll just clear this one. 3x minus y equals 7. And then our bottom one was 2x plus 4y equals 28, I believe. We'll double check that. 3x minus y equals 7. 2x plus 4y equals 28. And so I typed both of the equations in, it popped up my graphs, and then if I was to check it, 4, 5, and that's what we got. So it's super easy to use Desmos. It's really great to check all your math. But if you still need to take the ACT for school, for whatever reason, you need to know how to do it algebraically or how to put it into a graphing calculator, because you are allowed to use those as well. Okay, now when we go to graph this, we're going to need 2 more points, one for each line. So this one we're going to use on both of them. When I go to use this one, and I should quit showing y'all Desmos if I'm telling you, you might still need to use it. Okay, if you wanted to use Desmos, you just need to find another line. So like that purple one, I could use 0, 7. And then this green one, I'd just find an area where it crosses with that 6, 11. You can drag it on here and find like a good point. But let's go back here, because it also has to show up on our graph, and 6, 11 is not going to. Okay, so if I was doing this top one, since I have just y here, I'd put 0 in for x, because anything, that was hick, anything times 0 is 0. So then I have negative y equals 7. Y can't be negative, but I can divide by a -1 to move that. So negative divided by a negative is a positive. I'd have y equals 7, and my x is 0, so my point would be 0, 7, which is the one we just found. Looking at the bottom equation right here for my new point, I think I'd put 0 in for y, because it's just a big number. So if I put 0 in there, that's going to be too big though. Let me explain. So 4 times 0 is 0. I'd have 2x equals 28. And when I divide it by 2, that would be 14. But if I look at my graph over here, it stops at 10, so I won't have that on my graph. So let's go ahead and do, if I put 0 in for my x, 2 times 0 is 0, so then I have 4y equals 28. And I could divide by my 4, and that would give me y equals 7. Oh, this one right here is -7, y'all. When we divide it by the -1, it makes it -7. It's like they can't have the same intercept. Okay, so then we'd have our x is 0, and our y is +7. So just to make sure y'all saw what I did here, when I divided by my negative here to make my y positive, this also had to be divided by a negative, and a positive divided by a negative is a negative. So when I go to graph it, I'm going to do 4, 5, and then those intercepts that we just found. Where's my mouse? Cool. Oh. Drag you over here. So I'm going to graph our solution first, 4, 5. And be sure, like, I know I've said it before, 4, 5, it tells you your point in this upper corner. You can always make sure you're clicking the right one, because as these graphs get harder, it's just good to know that you can see it. Okay, I'm going to do the top one first, so it's 0, -7. Okay, then we're going to do 4, 5 again. Woohoo, 4, 5, and then my other one was 0, +7. Save, check. Okay. (3x equals 18) and x plus 2y equals 0. This one's actually really easy, even though it looks different and confusing. Since this is 3x equals 18, there's no y value. This is a vertical line, so we're going to have to solve for x, and we can right here because it's just x. 3 divided by 3 is 1. 18 divided by 3 is 6. So then we take this value and we're going to plug it in right here and figure out what our y value is. So I'm going to have, I guess, where do I want to write this? Oh, we'll do it here. 6 plus 2y equals 0. So I took the 6 we found from our top equation and I'm plugging it into the bottom one. This would technically be a substitution way of solving because I solved for this and I'm substituting it into this one, which I guess we've been doing substitution the whole time too if we look at it that way. Okay, so I'm going to subtract 6. 6 subtract 6 is 0. So I end up with 2y equals negative 6. Divide by 2. Y equals negative 3. Okay. So I'm going to have 6 and negative 3. Okay. Pick and choose what I want to get rid of here. This got to go. Sometimes I feel like this is faster, sometimes I feel like this is slower. Okay. When we do this top line, we're going to go ahead and do, it's everywhere that x is 6. So I have 6, negative 3. Our other one is going to be 6, 0. It could be anything though where it's 6, 6, 1, 6, 2, 6, 3, 4, 5, 6, 7, 8, 9, 10, whatever, as long as x is 6. And then our bottom one, let's do 0 in for y. So then I have x equals 0, so this one's going to be at 0, 0. So there's our 2 points, and let's graph it. I get up for 5 seconds and the mouse is gone. What am I clicking over here? It's not like I throw it every time I get up. Okay, 6, negative 3. And then we're graphing our top one, which is just x equals 6. So it does not matter any of them that I click as long as x is 6. I did do 6, 0 as that, and I just clicked 6, 5, but it doesn't make a difference. Okay. And then 6, negative 3, because that is our solution. And our point we found for our second equation was 0, 0. And you can always check these on Desmos as well. Okay. 2x plus y equals 3. 4x plus 2y equals 1. Looking at this one, I noticed that all of my signs are the same. I see that 2x and 4x, that's just being multiplied by 2. Y and 2y, that's being multiplied by 2. The 3 and 1 are not, though. In my head, I want to say this is just inconsistent right off, but we can go ahead and check this. Remember, inconsistent is where they never touch or cross because they are parallel. So 2x plus y equals 3 is our top one. 2x plus y equals 3 is our top one. And then it was 4x plus 2y equals 1. I'll double check that. 4x plus 2y equals 1. Okay. And then if I get that, these two are parallel. So remember, when the lines are parallel, I zoomed in real far. I just wanted it to not be huge numbers. When they're parallel, it's inconsistent because the solution is where they cross or touch. When they touch and they're the same exact line, that's when there is infinitely many. When they never touch, it's inconsistent. I do think we're going to have to graph these. So when you graph these two, you can do what we've been doing. You can find your intercepts, or you can use Desmos. I'm looking at this. If I found my x-intercept, it's going to be 3/2, which is 1/2, so that's not bad. My x-intercept here is going to be 1/4, though, which would be kind of hard to graph. Here, we'll go here and see. 0 and 1/2, 0 and 0.25, 1 1/2, and 0 and 3. I don't think I'm going to be able to graph the fourth. They are going by halves here, but not by fourths. That was one right. We'll double check. So I did a half here and 3 there. No, it's 1.5 and 3. So I'm going to go drag that one to 1.5 and 3. But then let's go back and see. I can do the half right here, but I can't do the quarter. Where is going to be? I can't graph quarters. Not what I'm wanting to do. But I don't think I can do that. Let's see. Yeah, we're stuck between 5s. Okay. I can graph my half, but I cannot graph so what is it at 4? Because it doesn't go past 5. What is it at 5? 2.25. What was that? 4.5 and -2. -2 and 4.5. Sounds great. -2. 4.5. Did that go wild? No. Okay. The top one is no issue. The bottom one, you're going to have to use 2 or 4. Okay, let's see. X plus 2y equals 8. 6x plus 12y equals 48. They all have the same signs. They're all positive. When they're all positive, I know that something is going on. Make sure it's still recording since I've been down here. So when everything's positive, I start looking to see if they're by a multiple. This one, if I multiply by 6, 6x. If I multiply by 6, 12y. 8 times 6 is 48. This one, I believe, is going to be the exact same line. We can check it. It won't be nowhere near as hard because we don't have to graph this one. I should have solved that last graph one by hand so y'all could see it. I'm sorry. If y'all would like me to do that, I most definitely will for you. But x plus 2y equals 8. I hit C. X plus 2y equals 8. And then they just multiplied everything by 6. So 6x plus 12y equals, here we go, 48. Same line. So when it's the same line, oh, this will be easy though. At least mine is. I've realized sometimes it gives me the easy problems. So here's our equations, exact same line. So when they're the same line, it's infinitely many solutions. And we have to solve it for x to put it into this option. So use the one that's not multiplied and exaggerated. So my top one, I would subtract my 2y because I need it to be x equals, so everything that's not x has to go. So 2y subtract 2y is 0. So x equals, I'm going to put the y first, it's just habit. And it's a positive 8, so plus 8. Now if I had like 2x or 3x, I would go ahead and divide by whatever is with my x value. I say that because I guarantee y'all probably have something with your x. If I had 2 with mine, I would have to reduce this because both of those are divisible by 2. But I'm trying to make sure in case y'all get a problem like that I don't have. Oh wait, this problem, I have 2x minus 2y equals negative 2, and then 5x plus y equals 7. So I'm going to need, you can still use Desmos on these. You're just having to find the solution. There's going to be a solution here. I'm going to solve this by elimination. So to get it, so to make it so that I can eliminate something, I need to multiply this bottom equation by 2 so that I have a 2y here that's opposite of the negative 2y. So I'm going to go ahead and bring this equation over so I can line them up when I go to add them. And then 2 times 5x gives us 10x. 2 times y would be positive 2y. 2 times 7 is 14. And then we'll go ahead and add our equations. So 10 plus 2x gives us 12x. I hate when I write on the words. I know it's hard to see. Negative 2y plus 2y is 0 there. And then negative 2 plus 14 is going to give us a negative 12. So because you can't see that, I'm going to rewrite it. I had the 12x equals, I don't know why I put negative 12. It's positive 12. And then divide by 12. 12 divided by 12 is 1. 12 divided by 12 is 1. Then pick either equation, whichever one. You can use the one that's been multiplied, the one that hasn't. It doesn't matter. They're all going to come out the same. I'm actually going to go back to our original one right there. And I'm going to do 5. And then instead of x, I'm putting my 1 in. Plus y equals 7. So I have 5 plus y equals 7. That's a horrible plus sign. Subtract 5. So y equals 2. So my answer is 1 and 2. X is 1, y is 2. One thing I've noticed is I'm always solving for x first. Maybe this next problem will give us one where we can use our, oh, nope. Change up. Word problem. I know they're your favorites. On these word problems, I'm a visual person. I like to draw them out. So we're going to draw a picture. The perimeter of a rectangular floor, so we have a rectangular floor. Perimeter of this floor is going to be 156 feet. Find the dimensions of the floor if the length is 5 times the width. So we have our width, and our length is 5 times the width. So when you do perimeter, that's the distance all the way around. So the original equation, I'll write it real quick. 2L, because you'd have 2 lengths, plus 2 widths, equals your perimeter. So that's just the basic formula. Now I'm going to put in what we have. So our L equals 5W, because length is 5 times the width. So instead of L, I'm going to put 5W here. I still just have 2 width. And then my perimeter is this 156 that they gave me. And then we'll solve this. So 2 times 5W is 10W plus 2W equals 156. So 12W equals 156. So W is 156 divided by 12, which is 13, right? I'm double checking. I don't like trusting myself on basic math. Yep. So W is 13. And then I'm going to write it right here. And our length is 5 times W, so 5 times 13. No, 5 times 12 is 60, but 5 times 13 is 65. I don't know why I get in my head about little numbers. Okay, that's it. Yep. So length is going to be 65 and width is going to be 13. And we can check this too by adding up 2 lengths and 2 widths to make sure. Look more. Go away. Click. Dang. Oh, 1 year there was a total of 84 commercial and non-commercial orbital launches worldwide. So right here is our first equation. 84 commercial and non-commercial orbital launches worldwide. The number of non-commercial orbital launches was 4 more than 3 times the number of commercial orbital launches. So non-commercial orbital launches was equals 4 more than 3 times the number of commercial. Determine the number of commercial and non-commercial orbital launches. I know that's a lot to words. So whatever the total is equals both of these added together. Remember that non-commercial is private, so there should be a lot more private than commercial. And then how they've done this, we have what n equals, so this is a substitution problem because we're just going to take this and put in for n here. So we're going to have 84 equals c plus, and then instead of n, we're putting 4 plus 3c. I put in parentheses for that moment. Okay, then we'll combine our c's over here. So I have 84 equals, it's going to be 4c plus 4. Then I'll subtract my 4, get my numbers together. 4 subtract 4 is 0 over here. 84 subtract 4 is going to give me 80 equals 4c. Divide by 4. 80 divided by 4 is 20. So we're going to have c equals 20. Now when you go to solve for your n, you can either plug it in here and do 3 times 20 is 60 plus 4 is 64, or 84 subtract 20. So however, I don't know, my mind always tells me to do this, but the easier way to do it is just take what you found and subtract it from the total. So it's 64. I don't know if that's just me being difficult, but as y'all know by now, my brain is not normal. Commercial was 20. Non-commercial, I think we have 1 more, 2 more, 2 more. Dang. Just go back. Maybe it'll be, sometimes it's faster, sometimes it's worse. A movie theater charges $8 for adults and $5 for senior citizens. On a day when 326 people paid for admission, the total receipts were 1,966. How many who paid were adults? How many were seniors? So first, we're going to do people, and then we're going to do money. So we had adults and seniors. So A plus S equals 326. Because total, that's how many people we had. Now we have to put our money with this, so $8 for adults, so I'm going to say 8A plus $5 for seniors. My S's and my 5's look alike. I hate when they do this to me. Equals the total amount of money. So total amount of people is just adults and seniors equal however many. Then money, put it with them, equals the total amount of money. We're going to solve this with substitution. So we have to solve for either A or S in our top equation and then plug it into the bottom. Which you could do it this way, but then you'd be solving with a fraction. Let's just subtract our seniors. That sounds aggressive. Okay. Yeah. So A equals 326, subtract S. and I'm going to substitute this A in right here. So I'm gonna scoot over here so I have more room. 326 subtract S equals plus 5S equals 1,966 because I substituted this in for A. I need a calculator because I have to do 8 times 326. 2,608. 2,608. And then you're going to do 8 times that, subtract S, and plus 5S. I'm trying to make sure my S's don't look like the 5, and it's, I'm going to combine my S's over here. So a -8 and plus 5, that's going to give me a -3S, which is okay because when I subtract this over, it's also going to be negative, and then the negative divided by a negative is going to make it positive again. Okay. I don't have room to write it. Dang. Not loving this. Okay. 2,608 subtract 3S equals 1,966. We're going to subtract the 2,608. I'm going to grab my calculator. This is 0, and I'm going to have -3S equals this number. Should put one up on the screen. $2,006. It's going to be -642, and then we're going to divide it by -3 so that it's going to be positive. So sorry for how crazy this got on here. 214 seniors. So we have 214 seniors. Then we're going to take this. I keep just wanting to draw more lines, but I think that just makes it crazier. We're going to take this 214 though and subtract it from 326 to get our total amount of adults. So I'm going to write this right here so it's not lost. And then I'm going to do 326 subtract 214, and we're going to have 112 adults because we had a total of this many people. So when we found our seniors, we just needed to subtract it to find our adults. I'm sorry that got so jumbled. Yeah. Oh, that was it for that lesson. I guess when I said 2 more, it just kept thinking in my head. 2 more.